Greetings and welcome to a video tutorial on files in Java. Now, I strongly recommend that you go and watch the generic file lecture if you've not already done so, and make sure you've done your reading. But with that little warning out of the way, let's get into it. Now, you will not need all of these imports every time you go to work with files in Java. Depends on what you are doing, really. If you are just writing to a file and not having to read from it, well, you're not going to need Scanner. Likewise, if you're just reading from a file and don't need to write back out to it, you won't need the file writer import either. But these are a set of fairly common imports that you will need for manipulating text files. File is for just general file operations. File writer is specifically for writing to files. All file operations will force you to catch exceptions, so you need to at least have I/O exception, maybe even more specific exceptions if you think they are warranted. And of course, we need Scanner for reading information from the file, just like we need Scanner to read information from the console. So let's see what we have going on here. First up, our try statement. Like I said, practically every file operation in Java will force you to handle thrown exceptions. You can't just ignore it like you can with, say, integer.parseInt. You have to catch these exceptions. So anytime you're doing something with files in Java, it is going to have to be in a try catch. So we have our try with our opening curly bracket up here. And then down below, we have our closing curly bracket, and we are catching an I/O exception and just simply doing a stack trace print should this happen, which it shouldn't for any of this example. Scrolling back up, we have two different ways of opening up a file. We can use the file class. So I've got file test equals new file input.txt. So a word about paths before we continue. In Eclipse, when I run a project, the root directory, so to speak, where this project will run is the top level project directory. So this CSD2522_files directory is where my program will be running from. That will be my root directory. And since my input and my output files are both in that same directory, I don't need any path information. You need to make sure that if that is not the case, if your files are not in the same location as where your program is being ran from, you will need to include path information. But in this particular case, we do not need to do this. So I'm using file to open up the input.txt. Remember, with file, you can't actually do much with the file. This is just for opening the file, maybe setting some parameters on the file, and finding out some general information about the file. But you can't read or write directly using the file class. If I want to write to a file, I want to use the file writer class. And again, I am passing in the file name that I want to write to. I could also, alternatively, have a second instance of the file class, open up that instance with the output.txt, and then pass the file object into the constructor for file writer, and that would also give me a valid file writer for writing information out to a file. For setting up to read the file, I'm going to use the scanner, and just instead of passing in system.out like we do for reading in from the console, we are going to pass in our file object, and the scanner will then use that to go, oh, okay, well, I guess I will be reading from this source, the file. Now, one of the more common ways of pulling all the information out of a file is to just have it in a while loop and just say, is there a next line? Now, there's some caveats to that. You need to make sure you understand what constitutes a line. We'll get to that. We're just going to ask, is there a next line? If so, ignore these comments for the moment. We are going to use scan.nextLine. Keep in mind this is scan.hasNextLine. We're just simply asking, does this exist? And here we're saying, okay, give me that next line and consume it, basically. Again, it doesn't literally take it out of the file. It just moves the pointer that's keeping track of where in the file you are. So we're saying scan to get the entire next line. I could also use nextInt since, well, that's what we're reading in ints. Storing it in the string line, and then I'm trying to do an integer.parseInt to get that string to an integer, so that way I can figure out, is it odd or even? So x mod 2, if it's 0, that means it's even, and if not, that means it's odd. And here we have our output. So I'm using the file writer instance that I created. I'm just saying output.write. Keep in mind that write, just like print, doesn't automatically kick things to the next line. I have to explicitly put in a new line code here for it to know to move things to the next line. Keep this in mind. We'll be coming back to this idea of new line codes here in a moment. And then finally, once I am done with these files, I need to close them. So I'm doing scan.close and output.close. Notice there is no test.close. In the case of the scanner, you just simply close the scanner, and that will also close out the underlying file as well. Java also has a thing where once a variable goes out of scope, it will automatically clean up that variable, so to speak. And if that's a file, then it will automatically close and clean up that file reference. So does it work? Well, if we hit F11 to run the program, and then I remember that I forgot to undo my changes from my practice, so hold on one moment. As I said, if we hit F11 to run the program, we'll get done reported down here. And if we open up our output, you can see that, yep, sure enough, there is output. And just to prove the point that, yes, it is generating this, if I delete out all the output text and I run the file again, there it is. There's all the information. And it's correct. If I look at my input, you know, odd, even, odd, even, odd, even, odd, even. Yep, it works. That is the correct output. So everything's great, right? Well, let's get back to that understanding of what a next line is. What happens if I have a blank line in my file? Well, it still works because I don't have a blank line in my file. Now, you might be looking at this and going, wait, hold on. I can clearly see that there is a line 11 in your input.txt file. What do you mean you don't have an extra line? Remember how new line codes work. And don't do this next part. Remember that there is an invisible new line code at the end of all of these lines. In the original file format, it looked like this. There is no new line code, so the file just ends right there. 5 is the literal last character in this file. But if I hit the Enter key, that doesn't put in a new line. What that does is it puts a new line code where the cursor was when I hit the Enter key. There is still no new line here. But if I hit the Enter key again, that would put in a new line code on line 11. Now, line 11 exists. Now there is data on line 11, even though, if I take out my little visual aids here, even though to our eyes, looking at the text editor like this, it seems like there's 2 blank lines, there's only 1 blank line, line 11. But line 11 does exist. There is data there. We just don't see it in the text editor. But when we go to read this information, we will find it. And so now integer is trying to throw a number format exception that has not been caught because it's trying to parse into an integer an empty string, because it's not going to bring in that invisible character as part of the string. So obviously that is going to give us an exception. It can't handle that. So how do we fix this? Well, one, by understanding our file format. Like, this is a list of numbers. We don't want empty lines at the end of it like this, so just delete them out. Make sure that your file format's correct. That's one way. But we do want to try to account for user error. Like, what happens if on line 7, for some reason, somebody put in a decimal? Integer.parse will not work on that, because you can't parse a decimal number into an integer. That's not how it works. So we need to catch that. So one way that we could do this is I could put in this try catch statement here, which is not ideal, but I'll get to why here in a moment. So if I put in this try catch with just the most generic catch statement here, exception E, now my code will work. If I run this, I get done. If I go to output.txt, I can see that line 7 reports as invalid and line 12 reports as invalid, which is correct. Line 12 is invalid. Line 7 is invalid. There is no line 13, so there is no output for line 13. So now it's going to work regardless of how many empty spaces there happens to be at the end, or if there's any invalid data in the input file. However, there is a major thing wrong with how I've done this. This would be a bad idea, because what happens if the error is with output.write or scan.nextLine? That's just going to cause even worse errors, because that means there's something wrong with my files, and I need to know that and handle the situation accordingly. But those errors will be caught by this ultra generic exception catch. So two ways of solving this. One, you always want to be as specific as possible when catching exceptions. I know that in this particular case, it is a number format exception that I am catching. And so instead of catching exception E, I should catch number format exception. Now, if there's an exception with output, this will not catch it. This will. And actually, let's pause a moment. Now, while I was going through and doing some practice runs on this, I suddenly had the thought of, wait a minute, why would I put the catch statement here? I could just chain my catch statements down here, which is a thing you can do, by the way. A try statement is not limited to a single catch statement. Oops, that you should not be there. Go away. You're not limited to a single catch statement. You can have multiple different catch statements because there could be multiple different exceptions that you could be encountering. So I could have a catch IO exception, and then I could have a catch number format exception down here, rather than trying to have this nested try statement. And on impulse, I was going to do that without testing it first, and then quickly figured out why that was a bad idea. Because I want to write out to the file, this was invalid. This was an invalid line. I want to have this format to the file here. But if I move this catch down to here, well, because I declared output inside this try statement, that is the scope of output. Notice something wrong here if I put a catch statement down here with an output.write statement in it. Doesn't work. I would have to completely re-architecture how I'm doing this try-catch statement to actually have a multi-catch here with the number format exception. So in the end, it does make more sense to leave it up here, even though it seems a little bit weird to have this nested try thing going on. So, moral of the story is just always be cautious with how you're structuring your files to make sure that you are not creating unnecessary work for yourself. And always have that pause and think of, wait a minute, why am I getting red squiggles of doom? To make sure that you understand why you're getting the red squiggles of doom. So that way you know whether or not that is something you need to fix or if you need to undo the change and do a different approach. And of course, because I don't think I've mentioned this yet, make sure you close your files as soon as you're done with them. Now, there is one more thing that I want to demonstrate, and that is the fact that you can very much so cause yourself data loss if you are not careful with how you handle things. This is why you want to handle exceptions. Because remember, if I'm running this program in the wild, it's not going to go into debug mode when it crashes. It's just going to crash. It's just going to stop. So what happens here? So I've got my output file. Output currently has information in it. Maybe I've now modified inputs, got some more data in it, whatever. All right, so I'm going to run my program again. So I'm going to run it. It has now crashed, so I'm going to stop execution because that sort of represents how it would work in the wild. You had an unhandled exception, so boom, your program's just going to end. Oh, hey, all my output.txt information's gone now. The file that I opened for writing is gone. Total data loss. So this is why it's very important when you're working with files to understand what kind of exceptions can happen and make sure that you are accounting for those. All right, let's go over the assignment. So for the assignment, bring over your primecheck.java file. For some reason, you were not able to finish this project. Remember, I do have a video up that basically shows my code solution to that particular project. So if necessary, implement that. But bring your primecheck.java file over from the prime review assignment. And you need to modify it so that it can send the output to a file called prime.txt. The output format should be the exact same as the original assignment. So in other words, every time you find a prime, that should be written out to the file. And at the very end of the file, you should report how many primes did you find and how long did it take. And again, we'll be finding all primes up to 200,000. For an extra 3 points of extra credit, don't hard code the file name to be prime.txt. Instead, have that being pulled from the command line. So go in and modify the command line arguments to give the file name prime.txt. But nowhere in your code can you have the string prime.txt if you want the extra credit points. And that is it. Good luck with the assignment. I'll catch you on the next video.